Hello everyone, so I hope you are doing okay. In this video, let's talk about the alkyne addition. In our previous video, if you remember, we have talked about the alkene addition. So that's another important thing in photochemistry. So I will put the link here, you can watch it if you have not. In this video, we are going to talk about the alkyne addition. Now, I will explain to you about this particular reaction mechanism based on another example, right? Let's take an example as we are going to take a ketone, and also let's take a alkyne. Okay. Now the first step, as before, the same thing like the alkene addition. One bond in our alkyne will go through the radical mechanism or radical breakthrough and come up with the formation of a bond along with oxygen. Now, like this, we have the product like okay, yeah, just like this. I hope it's okay, right? So here, look at this. If I number the carbon 1, 2, 3, 4. 2, 3 is the two carbons that has this alkyne structure. Now, when the bond is happening, the oxygen is going to form the bond between the second carbon. So here, this is the second carbon, this is the first carbon. 3 and 4. So when I put the numbering, I hope you understand how the reaction going through, the mechanism is going through. And then now you can see there are two radicals, so coupling can happen, right? A coupling can happen between these two. We will have the product like this one. So this is 1, this is 2, this is 3 and 4. Okay. Now there's a small difference compared to the alkene addition. Now in alkene addition, the reaction would stop from here. But in this case, we have another step, like there is another possibility to move on with the reaction. What is that? This product over here, we call this as oxytene, right? Oxytene. This is very destabilized, very unstable. So what happens is this bond over here, right? This bond over here and this particular pi bond over here is going to break like this. So we have two particular radicals, okay, like this. So there is a radical here, radical here, radical here, and radical here. These two comes together. These two comes together. We have our final product like this. Sorry. Okay, I hope now it's fine. So this is 1, this is 2, this is 3, and there's a 4 over here. So when you compare that, this is 1, this is 2, and this is 3, and there's a 4 here. Okay, so this is the final product which we have. Right, this is the final product. Now a small thing to remember, right? So step happening from here to here. So these steps are very fast, right? This rearrangement, this is a rearrangement step. So from here to here, it's a rearrangement. So this rearrangement happens really fast. So mostly these radicals can bind together in different forms. So in this case, I have drawn it in two steps, but it maybe in some dynamic situations it can go through with the single step or few steps. But however, it's the thing is the reaction from here to here, this rearrangement is really fast because this is very unstable. So you will have this particular product from here in very quick, very low times, right? I hope you understand the mechanism. So this is basically the alkyne addition.